Ladies and gentlemen, to this interactive session. I will be starting off with a talk on the basics of power. At the outset, I would like to state that I have no financial interest in the contents of this presentation. The Oxford Dictionary defines power as the ability to do or act. Practically, for us phacosurgeons, power is the ability of the phacotip to emulsify the cataract. The generation of this power goes back a long way. In 1883, a gentleman called Pierre Curie described what is called the piezoelectric effect. This effect was that if certain kinds of crystals were pressed physically, they generated an electrical impulse. In phaco, we use what is called the reverse piezoelectric effect. So if certain crystals are given an electrical impulse, they tend to move or vibrate physically. And this principle is used to provide the power to the phacotip. Once the power is generated in the handpiece by means of these crystals, the power is and thereby delivers the energy to the nucleus. The amplitude of this movement is called stroke length, and the velocity is around 13 meters per second, and the frequency varies from manufacturer to manufacturer, often in the range of as low as 28 to up to 60 kilohertz. Now these are all ultrasonic frequencies, and average has been around 35 to 45 kilohertz, which has been found to be a good mix between cutting ability and not causing a burn. There are a variety of tips available. The phacotip is now your final interaction with the nucleus. It is the point where the cataract meets the machine. And there are various angulations available ranging from 0 through 15, 30 and 45 degrees, even 60 degrees sometimes. It was earlier believed that the steeper the angle, the sharper the bevel, the more cutting you would get. This concept has now taken somewhat of a backstage, and in general we are quite happy with 15 or 30 degrees, which provide an efficient mix between cutting and holding properties of the tip. There are also designs available for the tip. Apart from the angulations, we have the standard tip, something called the Kelman tip, which I have shown here, which is a bent tip, and other types. I would specifically like to mention the Kelman tip here. It offers two very big advantages to the phacosurgeon. First of all, it is bent. So if you are sculpting a very hard cataract and you have to go really deep to do a 4-quadrant or a stop and chop, then a Kelman tip really takes the load off you. You can go deep without really staining your hand. That the bend achieves for you. And secondly and critically, this bend is instrumental for allowing you to use a torsional phacoemulsification, as will be discussed later. Torsional is a whole new way of delivering energy, and it can only be done if you are using a Kelman tip. You cannot do that with a straight tip. So this is a design for a Kelman tip. There is a controversy to a limited extent about how the actual mechanism of phaco is brought about. The most widely acknowledged way by which phaco breaks down the cataract is called the jackhammer effect, which is a physical movement. The to and fro movement of the phacotip physically destroys the cataract in close contact with it. There is also the shearing effect of the torsional phacoemulsification, which is also a physical effect. Some thought has been given to what is called the cavitation effect, which is basically implosion of microbubbles forming in front of the tip. There is some controversy here. Some people believe that microbubbles are a more important way of emulsification. However, research shows that although microbubbles form and are associated with a high level of energy in vitro, but in vivo the evidence has been less than compelling. So we are not very sure where we stand on cavitation bubbles. As of today, jackhammer effect and torsional forces are probably the more important things to consider. Once the power has been generated and delivered to the tip, the surgeon must now be able to control this power. In the earlier days, panel control was the standard thing to do. By panel control, what is meant that the surgeon sets all the parameters on the console itself, and then when you go from the foot pedal position 1 to 2 to 3, and position 3 is where you get the phaco energy, it's a kind of on-off effect. The moment you enter position 3, you get the whole power that you have set. And the moment you lift your pedal off there, the power is zero. So it's all or none. And this led to a lot of wastage of energy, a lot of excess energy, and there was no finesse at all. So now the standard is to go for a linear control. In a linear control, the excursion of the foot pedal in position 3 has been uniformly divided. So between a preset maximum and 0, the excursion will take you. If you have set a maximum of 40 power, for example, 40%, then at the top level where you enter the position 3, it's just about 0, and at the bottom it's going to be at 40%. This is how it works. The more you press, the more power you get depending upon your preset value. Now this is a very, very useful tool for the surgeon. You can press more if you want more power, less if you want less power, and thereby minimizing the use of your energy. Now, the importance of power here. Power is important because, of course, you need it to break the nucleus, but if you use power in a manner which is not consistent with the sound practices of phacoemulsification, you're going to end up damaging the eye. There can be damage if power is applied in excess or if it is applied at the wrong site. Excess energy can be delivered if you're using faulty settings on the machine. Now here the linear control is important to understand. For example, for a very soft cataract, if you have set a power setting of 40% or 50%, you will be able to deliver a lesser energy by pressing lesser. So you might get 10% by pressing a fraction of the amount on the foot pedal. But if in the beginning you set the power at 20%, then the whole excursion is available for you and your least count of excursion goes down. So you have a better range of movement and still you will not end up giving more energy than is needed. So the setting on the machine combined with the linear control gives you a much more efficient control on the amount of power you're delivering to the eye. Faulty foot pedal control is essentially when you are not very sure of the movement. For a beginner surgeon, this is more important. You tend to press more or less than what is needed, and that comes with time as you gain experience. You can also apply power to the improper site, which can then actually have no boundaries to the damage caused. And this is more to do with the control of the handpiece that you're holding in your hand. A good idea would be to stay in what is called the central safe zone. So the center of the anterior segment, both horizontally and vertically, is a good place to be. This is where all the intraocular structures are the farthest apart from each other. The more peripheral you get, the closer the structures start to crowd together. So in the center, you are well away from the endothelium as well as from the posterior capsule, and it gives you a margin of error. You can abuse power by not using it correctly, of course, but there are also situations where you don't have a say in it. For example, if it's a very hard cataract, you might still end up using a lot of energy in the eye, and it was necessary also. And in these cases, you can cause endothelial trauma, which can lead to a hazy cornea the same day, intraoperatively as well as the next day. You can cause a corneal wound burn with the attendant problems of a leaky wound and gross amount of astigmatism. And you can cause trabeculitis, which leads to a lot of high pressure for a sustained period of time. So you have to understand how and when and where to use the power. It has to be used with a proper understanding of fluidics. When you're doing phaco, power and fluidics go hand in hand, and as we are progressing in our learning, the importance of fluidics is taking on a greater role. Power is being pushed a little to the background, but you still need to understand how it works. You have to use more power for denser tissues like the nucleus, and when you move to a softer tissue like epinucleus, you have to shift to a lower setting. So you have to understand where to use what. The holy grail, as we say, is to minimize the use of power. You can do it in a number of ways. You can use power when necessary. For example, if you are trenching or sculpting and you are making a forward motion with your handpiece, you use the power you need to break it, but on the way back, you have to remember to lift your foot pedal. So your foot pedal has to be really finely controlled. You're not using power when it is not needed. You can use the machine setting to match the cataract, like I said earlier. If you have a softer cataract, do not set a higher power setting. You have to use the chopper as much as you can. A chopper is what physically breaks the nucleus. So in effect, it is going to do the job that otherwise the phaco tip would have had to do with the ultrasonic energy. So the more the use of the chopper is there, the better you are sparing your phaco energy. And finally, and most important of all, is power modulation, whereby instead of using a continuous delivery of phaco, you're using some form of an interrupted phaco delivery, which will be discussed in more detail in the next talk. You also have to remember to use enough power. When we say use low power or less power, you do not use so low a power that you cause trauma to the eye, because if you're using a very low power, you'll end up just pushing the nucleus, you'll cause zonular stress and you'll cause subluxation or dislocation and probably end up with complications there. So one has to learn the golden zone, not too less, not too much. Finally, apart from phaco power, there is one more way of delivering power into the eye, which is a exciting new technology called femtosecond laser, which we have all heard about. So essentially what femtosecond laser does is it breaks up the cataract primarily. It softens it up so that when you later go in with the phaco probe, you can emulsify it with much lesser power. Of course, you can also use it for creating the incision and the rexes as well. And on that note, I'd like to thank you very much.